This video is over Chapter 45, Parametric Equations in Area. Example 264 is going to ask us to find the area of the circle centered at 0, 0 and of radius 5 by integrating the appropriate region. Now, as you recall, this circle has equation x squared plus y squared is equal to 25. One way to do this problem is to solve for y. So we can have y as plus or minus the square root of 25 minus x squared, and look at the top half, or the bottom half, but the way I've set this up, we're looking at the top half of the circle, integrate from negative 5 to 5, and then multiply by 2. Now, doing this involves trig substitution. There is, however, a faster way to do this, and that is using Theorem 263. If we're going to use Theorem 263, then we express our circle as a plane curve using these two parametric equations. X is 5 cosine theta, y is 5 sine theta. X squared plus y squared is equal to 25. Then we integrate 0 to 2 pi because our parameter theta has to go from 0 to 2 pi. We integrate 0 to 2 pi of x times the derivative of y d theta. We could also integrate x prime y d theta. Then we take the absolute value. I've chosen to integrate xy prime. So x times y prime is going to be 25 cosine squared theta d theta. We take the absolute value. We didn't have to this time because the derivative of y is 5 cosine theta. And so we just multiply these two together. We have 25 cosine squared theta d theta. So that was positive, so we don't really need the absolute value here. But it is part of the formula, and in general, xy prime or x prime y won't always be positive, so we want to make sure we take the absolute value of our integral. Now we have 25 cosine squared theta d theta. This is just a trigonometric integral, an integral of a trig function. So we use one of our trig identities. So we have cosine squared theta. We just have 1/2 1 plus cosine 2 theta. So we just have the half angle identity here. And integrating cosine of 2 theta, we can do that fairly quickly. And so we just find an antiderivative, substitute 0, substitute 2 pi, and then we'll subtract. And so this simplifies to 25 pi, which of course we already knew that the area of a circle with radius 5 is going to be 25 pi.